Mm. Good morning, all. We'll start now. So, last class we have seen normal forms. Okay, Chomsky normal form we have seen. Now we'll see Griebach normal form. Okay, so I'll take one example and explain. So, what is Griebach normal form? In short form, it is also written as GNF. Okay, Griebach normal form. So, what is it? In Griebach normal form, left hand side we should have single terminal, a non-terminal, and the right hand side always start with the terminal and any number of non-terminals. Okay, so in other ways we can say V implies T V star. Grammar, all the productions in the grammar follows this rule. Okay, left hand side single non-terminal, right hand side always should start with a single terminal. We should not have multiple number of terminals also on the right hand side. And after the terminal, how many non-terminals also, we are not bothered about that. Okay. So here V star represents any number of repetition of non-terminals. It can be null, okay, no non-terminal or one or two or any number, but always start with the terminal symbol. Okay. So if a grammar follows the all this its production rules with this rule, then we'll say the grammar is in Griebach norm. Okay. To convert grammar into Griebach norm form, the algorithm will look like this. Step 1, ensure that grammar is in minimal form. Okay. Minimized form. What is minimized form? Minimal. Okay. Grammar should be in minimal form. What is minimal form? It should not contain unit production, useless symbol, okay, and a null production. We should ensure that we should eliminate everything from the grammar. Okay, if there any unit production, is there any useless symbol, is there any null production, we should remove everything, and the grammar should be in a minimal form. Means it should not contain any of this. Okay, should not contain unit production, useless production, and null production. So we should ensure that. That's the first step. If it is not in a minimal form, we have to convert into minimal form. Okay. Then in the second step, identify all the productions in the minimal grammar, because after first step, the grammar will be or should be in a minimal form. Okay. Identify all the productions of grammar and check whether they are in GNF or okay. GNF means always start with the single terminal and n number of non-terminals. Okay, identify it is in GNF or CNF. Okay, whether it is in GNF or So ensure that all the productions in the grammar is in GNF or CNF. Okay. And identify those productions which are which are in GNF and CNF. Okay. Now the productions which are not in GNF, convert. Okay. Right. Convert those productions into CNF. Okay. If not in GNF or CNF, then convert into CNF. So second step is identify all the production rules and check whether it is in GNF or CNF. If it is not in GNF, okay, all those productions convert into CNF. Chomsky form. Then in third step, okay, identify left recursion existing in the grammar. After converting to CNF, you may have what is CNF? In CNF, the grammar will be like this: V implies VV or T. Means left hand side you will have a single non-terminal, right hand side you will have two non-terminal or terminal. Okay, so obviously the right hand side will have the two non-terminals. Among the two non-terminals, one of the non-terminal may be repeating as in the left side. Whatever there in the left hand side, same thing may be repeating on the right hand side, the leftmost position on the right hand side. Then you may get a left recursion, like A implies A alpha. You may have like this. Okay. Then same non-terminal is repeating in the right hand side with okay. So that is a left recursion. So if there exists a left recursion, okay, then remove it. Then remove. Removal of left recursion, we have to do it. How to remove left recursion? If you are having a production rule like A implies A alpha, then we'll identify it as left recursion. We should remove that. Okay. So if you are having A implies A alpha beta, you convert this one into A implies beta x and x implies alpha x. That. Okay. So if you are replacing the production rule like this will be removing the left regression. Okay, so we have to follow here. If left regression existing, then remove left regression. Okay. Then in the fourth step, what we will do is now the grammar will contain all the productions either in GNF or CNF. Okay, and in the CNF also without left regression. So means entire grammar will contain the normal form. Okay, all the productions in the grammar is in the normal form. Okay, so we need to now identify the productions which are not in GNF. Because after that step, don't worry about simplification, don't worry about left regression. So, after third step, the entire grammar will be in normal form, which is either in GNF or CNF. Okay. Now identify the productions which are not in GNF. Identify the productions not in GNF. Okay, means it may be in the CNF product. Okay, Chomsky knows. If the production is not in GNF, then definitely it will be in CNF. Okay, so that's why then the fourth step, identify production rules not in GNF, means it will be in CNF. Okay, GNF. Then what we have to do? Then replace. Okay, or substitute leftmost non-terminal. Okay, leftmost non-terminal in the production rule with its production. Okay, this is a step. And a repeat. Okay, fifth step is repeat for. Repeat step number 4 until all the productions. Okay, repeat until all the productions in GNF. So these are the steps, five steps what we need to follow. First one is ensure that the given grammar is in minimum form. Okay. Second step is uh, identify or check all the productions and identify which are in GNF or, GNF or CNF. And if the production not in either GNF or CNF, convert those productions into CNF form. Okay, third step, identify the left recursion if exists. Okay, because after second step, all the productions will be in CNF or GNF. Okay. Now, if left recursion existing, remove left recursion because left recursion is will exist only in CNF, not in GNF. Because in GNF always will start with the terminal symbol, so we will not have any left recursion in GNF. But if the production is CNF, if, in the right hand side of the production may contain some kind of non-terminals. Okay, and if that non-terminal is same as the left hand side of the production, then definitely there is a chance of getting uh, left recursion. Okay, so if left recursion existing, then remove the left recursion. Okay, by applying the rule A implies A alpha slash beta with the A beta x and x implies alpha x null. We have seen all those type of production conversions and all. Now, fourth step is identify a production rule which is not in the GNF. Okay, identify a production which is not in GNF and then replace the leftmost non-terminal in the right hand side. Okay, what it means is if you are having a production like A implies B A C. Okay, you may have like this because you already removed the left recursion. So A implies ABC will not come. Okay, except that some other non-terms may be in the right hand side. And if you are having beta, B implies AB slash AB, something like this. Okay, ABC. Suppose you are having a production like A implies BAC, then B implies AB slash ABC. Then what you need to do? To convert this grammar into GNF, this leftmost non-terminal, that is B, we have to replace with this production. Okay. So what will happen is A implies instead of B, I write a production rule of B means AB. Then ABC. Okay. Then rest of the thing you write like this. Okay. So this will be replacing like this. Okay. A implies BAC will be converting like A implies ABAC slash ABCAC. It will convert like this. Now you look into this production, everything starting with the terminals. Okay, remaining n number of no terminals. So this is completely in GNF. That is a fourth step. Okay, and I repeat the step number 5 continuously within the grammar until all the productions are in GNF. Okay, clear? I hope it is clear. So these are the steps to be followed to convert any grammar into GNF form. Okay. So we'll take one example. Assuming that you are having a grammar is implies AB slash AB, then A implies AB slash AB slash A, B implies bxp slash xt. X implies A, P implies B. Okay, assume like this. You have the production rule like this. Then what is the first step? You have to minimize the grammar. Okay, this is your grammar and B also here. You have to minimize, ensure that grammar is in minimal form. What are the things we need to consider for minimal form? In minimal form, you should not have any useless symbol. Okay, we don't have any useless symbol in this grammar. And another one is we should not have any unit production. And we are having a unit production in this grammar. This is a unit production. Okay, unit production is existing like A implies B. Then we should not have any null production. Here, no null production. Only one problem, the unit production. So we have to remove unit production. How to remove unit production? Unit production. What is unit production? If you are having any production of the form V implies V, means non-terminal implies a single non-terminal. Okay. So to remove unit production, what we'll do? We have to replace the unit production, okay, with its production rule on the right hand side. Okay. So here this B we have to replace with its production rule. So what is a production rule for B? We'll be replacing with the BXP slash XP. Okay, instead of B, we'll write BXP slash XP. Okay, so the simplified form or minimal grammar will be looking like this. S implies AB slash AB, then A implies AB slash AB slash A slash BXP slash XP. Okay. Now X implies A and P implies B also. Okay, I hope it is clear. Useless symbol, unit production and null production. Everything removed. Now the grammar, this, whatever I have written the red color, it is in minimal form. Okay, this is in a minimal form. Now this minimal grammar we can consider for our normal form. Okay, normalization. So first step is over. Minimal form. Now second step, what is that? Identify the grammar with okay, all the production rules in the grammar and which are GNF and CNF. Okay, and which are not in GNF and CNF, we have to convert into CNF. That is a second step. So in the second step, what I use mother instead of red, I use green. This first step. Okay. Minimization. In the second step, what we will do is I use red color. Okay. Identify the production. Okay. Identify from the grammar. It is in CNF or GNF. Okay. So except BXP, everything is in a, either GNF or CNF. Okay. Except oh sorry, that also in GNF. That also in GNF. So in this grammar, all the productions are either in GNF or in CNF. Okay. Now, what is next is third step. Let's see what is third step. Second step we can skip because it is already in GNF or CNF. Third step is if left regression is existing, remove the left regression. Okay. So second step we are skipping. Okay. Second step. What was the second step? If there are any production which is not in GNF or CNF, identify their things and convert into CNF. Already in because See, all the productions are starting with the terminal. Okay. Otherwise, if not starting with the terminal, it is starting with the, it will have only exactly two non-terminal. See, AB, then XP, like that. Okay. Otherwise, it will be a terminal starting with the terminal symbol. So we have GNF production side mark AB, BXP, AB. Okay. Whatever I marked with green color, all are in GNF form. Then remaining CNF. Okay. The third step, what we'll do, check the CNF productions and check whether it is containing a left recursion or not. Okay. What is left recursion? What are the productions? Okay. What are the production rule you are maintaining on the left hand side? Same thing if repeating on the first position in the production group. See, A implies XP. Sorry, A implies AB. So A and A is repeating. So those kind of productions are known as left recursion. So if any left recursion existing, we have to remove those type of left recursions. Okay. Okay. So here in our case, which are the left recursions? Here, A implies AB will be a left recursion. So what we need to do? Remove left recursion. So to remove left, that is a step 3, removal of left recursion. To remove left recursion, what we need to do? Any production of the form A implies A alpha, beta 1, beta 2 and all. So we'll avoid left recursive productions. Okay. So A implies A alpha is creating problem. So rest of the thing I write beta 1, beta 2. So then along with the rest of the thing, you will be introducing some new variable. Okay, let us say it is M. And introduce new variable with the production. Okay, alpha M slash epsilon. So in the whatever you removed, okay, that in that only one recursive variable will be there. Remaining all variable will be introducing along with the new variable. So here I am introducing M, then M implies alpha M slash M. This is the rule to remove left recursion. Okay. Now in our grammar, A implies AB is there. That is a left recursive grammar. Then we need to remove that left recursion. Okay. So after removing left recursion, what will be the grammar? S implies A slash AB. Then A implies AB. Okay, because A implies that a capital letter B is creating an issue. So we should not write that. Remaining everything will write as it is. AB, XP. So here again one problem is there. AB, XP. Then XP. Then see here AB, XP and XP does not have any left recursion. So we are writing only those things and we are going to introduce new variable. Okay. Any new variable we can write. So I am writing M. Then introduce new variable with the production rules. So for introducing that one, what we'll do? A implies AB was a problem. So you will continue with the B. So B M slash null. Then X implies A and P implies B. So this is a grammar after removal of okay. After removal of left recursion, what will happen? The grammar will contain null production. Okay. So we should remove that null production. How to remove null production? Assuming that that particular data or particular variable is null in all the production. See here we are having a null production. So we need to remove that. So the resultant grammar or minimization. Okay. minimal grammar after removal of left recursion will look like this. S implies AA slash AB and A implies ABM slash ABXPM slash XPM. So in this productions, okay, assuming that this M is null everywhere. So the first case ABM, there M is null, only AB will be there. Second case ABXPM. Okay. In that case, if M is null, you will get ABXP slash last one XPM. So assuming M is null, only XP will come. Okay, you will have productions like this. Then M implies EM slash we are having null. Okay, so M is assuming M is null, so only B will come. Okay, then X implies A and P implies B. Again, here you are having a unit production. Okay. I forgot right one thing there. P index B slash XP. Okay. So I have to write B XP slash. So B implies B XP slash XP. Okay. So to remove this null production, we'll replace B with the BXP slash. Okay. So we'll remove that unit production with its production. So you'll get a grammar like this. Okay. So after third step, your grammar will look like this. A symbol is AB, capital letter AB, then all the productions. X, P, B. Now third step is over. What is the fourth step? Okay, after removal of the left recursion, all the grammar productions are either in GNF or in CNF. Okay. So what we need to do, identify the productions which is not in GNF. Okay. Then convert those into, that means it will either in GNF or CNF. Okay. So identify those production rules and convert those productions into GNF. See here, S implies AB. That is not in GNF. XPM not in GNF. XP not in GNF. BM not in GNF. Then XP not in. Here again XP. Okay, I hope all of you understood this. Okay, so all these green color things we need to convert into GNF. How you'll convert into GNF? These GNF things. Okay. Now in the fourth step, what we'll do is the identify non-GNF productions and there what are coming in the right hand side of the production. Okay. There the leftmost non-terminal you replace with its production. So in your grammar S implies AA slash. Okay, this A will be there. Okay, instead of that A, you will be writing its production rule. So ABM slash ABXPM slash XPM slash AB slash ABXP slash XP. Okay. So instead of this A, you are writing like this. Then after A, B also should be there. So that will be what you write. Okay, are you getting? Are you getting the idea? Okay, so the production rule S implies AA slash AB will become like this. Okay, this may be the big one because instead of A, you will be replacing with its production rule. Now you look into next production A. A implies only one XPM and XP. Okay, those cases are not in GNF. Remaining everything will be same. ABXPM slash AB. First I will write all GNF productions. ABXP. Now XPM is not in GNF. So what is in the leftmost side? X. That X will be replacing with its production rule. What is production rule of X? Small letter A. Okay. So APM. Then which is that XP. That also not in GNF. So that also will replace with the small letter A. So the production A implies that the production will become like this. What I have written the green color. That okay. Then where is it? Okay, here. M implies BM. There B we need to replace with the production rule. Then M implies XP. There X we have to replace with the production. So the production M becomes BM. Instead of B, you will be writing BXP slash XP. Okay. So after that, M also will come. Slash BXP, then slash XP. That X we have to replace with the production rule. So AP. So M implies BM slash BXP slash XP will look like this now. Now X implies A, don't have any issue. P implies B, does not have any issue. Okay. Now B implies BXP slash capital letter XP. What is X? X we have to replace with the production rule. Okay, so it becomes AP. I hope all of you are getting the idea. Okay, now we need to repeat the step. That is step number 5. Repeat the same procedure again and again in the same grammar to ensure that all productions are GNF. So what we'll do? Identify any production is not in GNF. Yes, here and here and here. Okay, 3 productions are not in GNF. Okay, what is there? There everywhere you are getting X. So remove that X with its production rule. What is production rule for X? Production rule for X is small letter A. Okay, so in those places that X you will be replacing with its production rule small letter A. Okay, anywhere else? No, only that 2 places. Here also. Okay, so in those places you will be writing small letter A, here small letter A, and here also we'll use small letter A. That was our last step. Okay, here I have replaced, here I have replaced, and here also I have replaced. Okay, so I hope now I check all the productions. Now all the productions will be in GNF form. Means all the productions are starting with the terminal symbol. Either a single terminal or starting with the terminal symbol. Okay. Now in the whatever you are seeing the green color, it is in GNF form. Okay. Step 4 and 5. After 5th step, the complete grammar which you are seeing the blue color in GNF. Okay, this is the resultant grammar. Okay, this is the original grammar and this is the resultant grammar. Hope everybody understood this. If anybody is having any doubt, please rejoin. Okay, now the class will be ending. Rejoin, so we'll have another problem.